welcome to the class. Today we shall begin with the new chapter, that is chapter number 12, Introduction to Three-Dimensional Geometry. So we all have an idea about two dimension, right? What it is actually two dimension? We are going to just consider xy plane, right? It is for two dimensional. So this is going to be our x coordinate and this is y coordinate. The same way it is negative x axis, which we are going to represent as x dash, and this is going to be the negative y coordinate, negative y, that is nothing but y dash. If we want to locate or if we want to find the distance of any point in this two-dimensional space, what we used to do? We used to find the distance between the x from the x and y coordinates. Then what we could say? We could say p of x comma y. This is how we used to find the distance of any point from in this two-dimensional plane, right? Now the same way we are going to study about three dimension. For example, now we are not going to say it as a plane, we are going to say it as a space. For example, see, you have rolled a ball, okay? The distance of, suppose the ball is standing here in a three-dimensional geometry, you want to find the place where the ball is standing, right? Here what we are going to consider? We are going to consider, because it is a space, we have three coordinates, that is x, y and z. So this is how is for three-dimensional geometry. Here we are going to consider three coordinates, which is y, z and x. Okay, these are the positive coordinates, that is the x is positive, y is positive and z is positive. Here this is going to be z dash, nothing but the negative, okay, the negative points of these z coordinates. The same way this is going to be y dash, negative y axis, and this is going to be x dash, and where all these points are meeting we say it as origin and denote that as O. See, if any point is in the space, for example here the ball is lying in the space, you need to find the distance, right, where it is. So for that we should now find what is its distance from the x-axis, from the y-axis as well as from z-axis. So then we are going to find, suppose see here, P is any point in the space. What it is? P, it is any point in the space. Then if you want to find its distance, how we are going to say? We are going to say that its distance should be found with respect to y-axis, z-axis and also with respect to the x-axis. Then only we can find the position of this point P. See, here we had four quadrants in this two-dimensional, right? It was first quadrant, second quadrant, third quadrant and fourth quadrant. But what happens here in this three-dimensional spaces, we are going to get 8 quadrants. How many quadrants? We are going to get 8 quadrants. So which are those 8 quadrants is? We can say it as x, o, y and z will be one quadrant. See, here we are going to get totally 8 quadrants. So what happens actually is, which are those 8 quadrants? One is x, o, y, z. For three-dimensionalities, it is x, o, y, z, x dash, o, y, z, and then the others are going to be what? X dash, o, y, z, y dash, x dash, o, y dash, z, and then we are going to get how many we got? 1, 2, 3, and again the fourth quadrant is going to be what? X, o, y, x, o, y and z dash, x, o, y, z dash we have. Then we have x, o, y dash, X, O, Y dash, Z. So 1, 2, 3, 4, 5 quadrants, and then we are going to have the next one is X dash O, Y dash, Z dash. X dash O, Y dash, Z dash. So next the other quadrant is going to be X, O, Y dash, Z dash. X, O, Y dash, Z dash. So how many we got? We got X, O, Y, Z, X dash, O, Y, Z, and then we got these quadrants as X dash, O, Y dash and Z dash. Then we are going to have X, O, Y, Z dash, X dash, O, Y, Z, that is X dash, O, Y dash and Z, right? These are the 8 quadrants. See here, X, O, Y, Z. Like that, totally we are going to get 8 quadrants in this 3-dimensional space. What we got? We got these 8 quadrants. That is, for 2-dimensional we had 4, and for 3-dimensional space we have 8. Because it is 4, we said quadrant. Now here we have 8, that is why we say what? We say that as octant, okay? We here say them as octant. What we have done here? We have found the coordinate axis and coordinate plane. These are what? Coordinate axis and coordinate planes in what? In this is with respect to the 3-dimensional space. Okay, how we are going to locate here any point P? It is located by X, Y and Z. Why it is X, Y and Z is because we are going to find this P or the position of point P with respect to X axis, Y axis and Z axis. This is how we are going to locate the point. Now let us next see about coordinates of a point in a space. What we are going to see? We are going to see about the coordinates of a point in a space. How we are going to locate these coordinates. Okay, coordinate of a point in space. Coordinate of a point in space. As I said, in space we want what? X, Y and Z axis, right? So this is what we are going to get, or better we shall draw a simple plane. That is, let this be Z, Y and X. Okay, X, Y and Z. We have any point P of X, Y, Z. We want to find its position. How we are going to do? We are going to draw one line, this parallel to Z axis. Let the foot of this line be M. Okay. Now what we are going to do is join it. Fine. Then we are going to get what? We are going to get X, Y and Z. What are those X? This is our origin, right? The distance, let this be what? Let name it as A. The distance from O to A is X. Here this is going to be what? It is Y, and this distance, what we are going to say? We are going to say it as Z. So this is how we are going to find its distance. That is what we have done. Given fixed point P in space, what we have done actually? We drop some perpendicular, means we have drawn PM, right? How it is? It is perpendicular on the XY plane with M as what? M as the foot of this perpendicular. We have drawn PM perpendicular to this XY plane as what? M is the foot of this perpendicular line drawn. then what is going to happen? Then actually, then from the point M, we draw a perpendicular foot, that is, we have drawn MA, then as x-axis, and we have located x, y and z. Now what we have done is, the point P in the space, there corresponds an ordered triplet x, y, z of real numbers. This point P, it is a triplet. It consists of 3 points. And how are these triplets? They are the real numbers, that P of x, y, z. It is an ordered triplet where these x, y and z are the real numbers. Now what we shall do is, see, when we were dealing with a plane x, x dash, y and y dash, we were knowing that here in the first quadrant both x and y are positive. In the second quadrant we have x as negative and y as positive. The same way in the third quadrant we had both x and y negative. In the fourth quadrant we had x positive and y negative. This was how we used to represent signs in this two-dimensional plane, right? Now the same way what we are going to do is, we are going to know the signs of x, y and z coordinates in this three-dimensional space. That is, we are going to say it as octants. We are not going to say quadrants. What we are going to say? We are going to say it as octants. That is, octants. Okay. Octants, they are 8, and then coordinates. How many coordinates we have? 3 coordinates. Right. We want one more, that is for x, y and z. How many we have? 1, 2, 3, 4, 5, 6, 7, 8. Total how many? 8 octants, right? Now see, what is going to happen is, let me draw the figure once more along that three-dimensional space. Okay. Right, it was y, z, y dash, z dash, x and x dash. So in the first quadrant along x, o, y and z, we are going to get all these as positive. We are going to get x, y and z, all three positive. The next way what we are going to get is, here our next plane we are going to get in the second quadrant where it is origin. This is origin. So in the second plane what is going to happen is, x is going to be negative. First what we shall do is, we shall write all those 8 quadrants. Okay, then we are going, it will be easy for us to identify. That is x, o, y, z, and then we have x dash, o, y, z, and then we are going to have x dash, o, y dash, z, then we have x, o, y dash, z, x, o, y dash, z, x, o, y, x, o, y, z dash. Then I have what? I have x dash, o, y, z dash. Then it is XO Y dash Z dash. 1, 2, 3, 4, 5, 6 and 7. We are left with X dash O Y dash Z dash. See, our first quadrant where we considered here as X, O here is all the time origin. So, we are just going to focus on X, Y and Z coordinates. Okay, X, Y and Z all are positive. Next, in the second quadrant I have X dash. X dash means what? It is negative. Therefore, our in the second quadrant we have X as negative, Y as positive and Z as positive. What about the third quadrant we have? Here it is going to be negative because it is X dash, and Y dash is also going to be negative. And what about Z? Z is positive. Next we have X. X is going to be positive. Y dash means it is negative. And then Z, it is positive. Again we have X positive, Y positive and Z dash is negative. Then we have what? X dash, Y is going to be positive and Z dash. Then we have X dash, we have X dash, Y dash and Z dash. Then we have X, Y dash, Z dash. X, O, Y dash, Z dash. These were supposed to be our 8 quadrants, right? See, in the first quadrant all the 3 are positive. In the second quadrant X is negative. Third quadrant both X and Y are negative whereas Z is positive. And then what we have? In the fourth quadrant X and Z are positive whereas Y is negative. Like that, along with these 8 octants we have what? These signs. So next what we are going, this is how we are going to find the signs of these coordinates. Next what we are going to do is we are going to solve the exercise. Okay, let these be here on the board itself, so that it is very easy to identify in which plane or in which plane those points are going to lie. Let us solve the first exercise, that is exercise 12.1. Exercise. This is just the basic chapter you have, which is going to help you in the next year, where you have, and in the second PU also you have a chapter called 3-dimensional geometry, where these concepts are going to help you. Okay, now let us solve. See, what is the first problem? They have given that a point is on the x-axis. What are its y coordinate and z coordinates? What they have given? A point is on x-axis. What are its y coordinates and z coordinate? See what they have given. They have given that the point is lying on the x-axis. The point is lying on the x-axis in the sense what? It simply means, for example, when we were using for 2-dimensional geometry, just compare with 2-dimensional geometry. When we used to say that the point is on the y-axis, or when we used to say that the point is on the x-axis, we used to say that y is going to be 0. The same way, if they have given that the point is on the x-axis, then both the value of y coordinate and z coordinate will be equal to 0. Right? What they have given? Since a point is on x-axis, what we are going to say? Since a point is on x-axis, what we are supposed to find? What are its y coordinates and z coordinate? Then the coordinates of y and z are what? They are a 0. Then the coordinates of y and z are what? 0. Why? Because I have said you that when any point, see the same way, if the point is, this is x, this is y and this is z. The same way if the point is on y axis, we say that x and z are 0. And again if the point is on z axis, x and y will be what? They will be 0. Hence how we are going to represent this? We are going to represent this as x 0 and 0. Why 0 and 0? Because the value of the y and z coordinates are 0. So our answer is x comma 0 comma 0. So what is the next question? They have given a point is in the xy plane. A point. Second question, look over the second question. What they have given? A point is in the xy plane. A point is in the xy plane. What we are supposed to find? Xy plane. What can you say about its y coordinate? What can you say about its y coordinate? Okay, this is the given question. What actually they have given? They have given that here a point is in the, okay, it is in the xz plane. See, we have x, y and z. What they are telling? They are telling that the point lies in this xz plane. Then if it is in the xz plane, what is about its y coordinate? If it is in the xz plane, the y coordinate will be 0. Since a point is in the xz plane, what can you say about its y coordinate? The y coordinate is 0. So if it is in the x, the same way if it was in the xy plane, the z coordinate will be 0, and if it is in the yz plane, the x coordinate would be equal to 0. I hope you all are following this. They have asked the point is in the xz plane. Xz plane in the sense what? Here the value of y coordinate will be equal to 0. Next, let us solve one more problem. They have given us a few set of points. We are supposed to identify in which plane they are going to belong. Name the octants in which the following points lie. What is the given question? Name the octants. Name the octants in which the following points belong. Okay, among that what is the first one given? The first one they have given is 1, 2, 3. They have given the points as 1, 2, 3. See these points here. X is positive, y is positive, and also z is positive. What we can write? In the given set of points, what has happened here? X, in the sense the value of x is 1, which is positive. Y is 2, the value of y here is 2 which is positive, and here z is 3 which is also positive. So how we are going to write? In the given set of points, x is positive, y is positive, and also z is positive. So look over this table where we find all the three positive, that is x is positive, y is positive, and z is positive. Therefore, these set of points belong to the first octant. That is 1, 2, 3 belongs to which octant? Belongs to first octant. Why? Because x, y and z, all the three are positive. Now let us see the next question. It is 4 minus 2, 3. What it is? 4 minus 2, 3. Look over the points. What about x? X is positive. What about y? Y is minus 2. Minus 2 in the sense what? Y is negative. And what about z? Z is equals to 3, which is positive. So what will come to know from that? That is x is positive, y is negative, and z is positive. It means it is in the fourth octant. What happened? It is in the fourth octant. The same way, what about the third question? Third point they have given as 4 minus 2 minus 5. 4 minus 2 minus 5. See here, x, it is positive. What about y? Y minus 2 in the sense y is negative. And what about the z? Z is also negative. In which octant we are going to find it? See, x is positive, okay, y is negative, and also z is negative. In the sense we are going to find this in the 8th octant. 8th octant. Like that they have given many more points. You try to solve it on yourself. Okay. Now let us move to the next part. Let us solve the fourth problem, which is fill in the blanks. Okay. Fill in what they have given: the x-axis and y-axis taken together determine a plane and what it is known as. See, if it has only two planes, that is x plane and x-axis and y-axis taken together, then we say as what? We say that as xy plane. Okay. Next, what is the question given? The coordinates of points in the xy plane are of the form. In the xy plane, of course, we are going to get x coordinate and we are going to get y coordinate. As we were discussing in the previous problem, I said that in the xy plane, z coordinate will be equal to 0. Then how we are going to write these coordinates? It is going to be x, y and 0. Why? What is the reason? Because in the xy plane, z coordinate will be what? Z coordinate will be 0. That is why we write x comma y comma 0. And the next question is, coordinate planes divide the space into, see, in the planes, in the two-dimensional, we said we have 4 quadrants. The same way in this coordinate plates, how many we have? I said it is 8. 8 is nothing but what? How many octants? 8 octants. Our answer is going to be 8. That is, coordinate planes divide the space into 8 octants. This is all about exercise 12.1. Now, let us discuss one more topic, which is that to calculate the distance between 2 points. What we are going to find? Distance between 2 points. distance between two points. Okay, in this three-dimensional space, let us assume 2 points as P of x1, y1, z1 and the other point is Q of x2, y2, z2. So how we are going to find its distance? We have already studied that in two-dimensional space, that is PQ will be equal to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is how we are going to find the distance between 2 points. Okay, depending on this formula, let us solve few problems. Let this be here on the board. That is, now we are going to start solving exercise 12.2. Exercise 12.2. So what is the first question given? The first question is that find the distance between the following pair of points. What they have given? Find the distance between the following pair of points. Means they have given us the points, we are supposed to find the distance between those 2 points. Among that, what is the first question given? The first question, the points given are 2, 3, 5 and 4, 3, 1. 2, 3, 5 and 4, 3, 1. Now let us find its distance. To find its distance, let us name those points. How we are going to name those points? Let those points be P of 2, 3, 5 and let the other point be what? Q of 4, 3, 1. It means it is going to be P of x1, y1, z1 and it is going to be Q of x2, y2 and z2. So what is the formula to calculate the distance between 2 points? We have that as PQ is equals to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, next find the answer. What it is? X2 we have as 4. Next, that is 4 minus 2. X1 we have as 2. 4 minus 2 square plus what is y2 here? Here y2 we have as 3. That is 3 minus what is y1? Y1 is also 3. That is 3 minus 3 square again plus what is the value of z2? Z2 is 1 here. 1 minus z1 is 5. That is we got 1 minus 5 whole square. On further simplifying, what we are going to get? Find out that as root of 4 minus 2 is 2 square plus 3 minus 3 is going to be 0 and the square of 0 is 0 itself plus I have 1 minus 5 means I am supposed to subtract 1 from 5, that is 4 and the bigger number has minus sign, it is going to be minus 4 square. So what I am going to write? It is 2 square is 4 plus 4 square is 16. Nothing but I am going to get that as root of 20. How I can further simplify this root of 20? I can write that as root of 4 into 5, nothing but the square of 4 is 2. I can write that as root of 2 square into root of 5. Now square and root is going to get cancelled. I am left with 2 root 5. So what is the distance between these 2 points P and Q? It is 2 root 5. That is the distance between P of 2, 3, 5 and Q of 4, 3, 1 is what? It is 2 root 5. Now let us solve few more problems. Okay. What is the second problem given? It is given that the 2 points are minus 3, 7, 2, minus 3, 7, 2, and one more point given is 2, 4, minus 1. 2, 4, minus 1. Let us name it like P of minus 3, 7, 2, and what we are going to get? Q of 2, 4 and minus 1. See what we have x1. x1 is equals to minus 3, y1 is 7 and z1 is equals to 2. The same here I have x2 is equals to 2, y2 is 4 and z2 is equals to minus 1. And what is the formula to calculate the distance between 2 points? It is PQ is equals to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is what we have the formula. Now substitute these values. What I am going to get? I have x2 as 2, x1 as minus 3 and I already have here minus. It is minus of minus 3 square plus what about y2? y2 is 4 minus y1 is 7 square plus I have z2 as minus 1 and z1 as 2 minus 1 minus 2 square. That I am going to get it as root of 2 minus of minus 3 is plus 3. 2 plus 3 is going to be 5 square plus 4 minus 7. It is minus 3 square plus minus 1 minus 2 is minus 3 square. On further simplifying, what I am going to get? PQ will be equal to root of 5 square is 25 plus 3 square is 9. Again 3 square is 9. That is, I am going to get 25 plus 9 plus 9 whose value will be equal to root of 43. That is, the distance between the 2 points is root of 43. The same way we have another 2 problems. You try to solve it by yourselves. Now let us move to the next main. Okay. What is the second problem given? They have given, show that the points they have given 3 points. Which are those 3 points? Those 3 points are minus 2, 3, 5, minus 2, 3, 5 and the other is 1, 2, 3 and 1, 2, 3 and another point is 7, 0, minus 1. 7, 0, minus 1 are collinear. We are supposed to show that all these 3 points are collinear. What is the meaning of collinear? It means that all these 3 points should lie on the same plane, right? They have given that we need to show that these points are collinear, means we have to show that all these 3 points, set of points, they lie on the same line. How we are going to find its solution? Collinear in the sense, what we are going to do? First name them, that is P, let that be equal to minus 2, 3, 5 and Q, let that be equal to 1, 2, 3 and R, let that be equal to 7, 0, minus 1. Let us first find PQ, QR and PR. Okay. What is PQ? root of x2 minus x1 means 1 minus 2. 1 minus of minus 2, right? 1 minus of minus 2 square plus y2 is 2 minus 3 square plus 3 minus 5 square. That I am going to get as root of 1. Minus into minus is plus. 1 plus 2 square plus minus 1 square plus minus 2 square. That I am going to get as what? 3 square plus 1 plus 4. Nothing but 9 plus 1 plus 4, that is root of 14. I got PQ as root of 14. Next, what about QR? QR will be equal to root of 7 minus 1 whole square plus I have 0 minus 2 square plus minus 1 minus 3 square. That I am going to get as 6 square plus minus 2 square plus minus 4 square. Nothing but 6 square is 36 plus minus 2 square is 4 plus 4 square is 16. I got it as 36 plus 4 plus 16. Then what I am going to get? I am going to get that as root of 56. How much? Root of 56. How can I write this root of 56? I can write this root of 56 as 4 into 14. Nothing but I can write this as 2 root 14. This is about QR. And what about PR? What I am going to get as PR? See, 7 minus of minus 2 square plus 0 minus 3 square plus what I have? Minus 1 minus 5 square. Then I am going to get that as 7 plus 2 is 9 square plus minus 3 square plus minus 6 square. That I am going to get as 9 square is 81 plus 3 square is 9 plus 6 square is 36. I got that as 81 plus 9 plus 36, which is nothing but root of 126. This I can write as 9 into 14, nothing but 3 root 14. So now what we are going to do is, I am going to write that as PQ plus QR will be equal to, what is PQ? I got PQ as root 14. I got PQ as root 14 plus what about QR? QR is 2 root 14. 2 root 14, which is here nothing we have in the sense, here the coefficient is 1. That's why 2 plus 1 is going to be 3 root 14. What we can write, see the value 3 root 14 is equals to PR. That is why we can write this as PR. Hence what happened? All these 3 points are collinear. Hence we proved that these points are collinear. So students, I hope you all have followed the topics discussed today and the problems solved today in this session. In our next session, we are going to solve a few more problems related to the distance of the point, and also we are going to study about section formula. Till then, stay safe and keep studying. Thank you.